Opportunities lost. If we think about the history of Britain, we might look at the big events, World War One, World War Two, the Industrial Revolution. If you're patriotic enough, you might know about the history of the empire, although I don't think that's been taught in schools nowadays. But despite the huge inventive and innovative talent in this country, there are gaps in our history, opportunities for revolutions in science, technology, and the economy, opportunities to maintain Britain's position in the world as an economic superpower, opportunities that have been lost. They've either been ignored, discarded, or been treated with indifference. And it's perhaps worth reflecting on the last 100 years to see what we've lost and how we can perhaps learn the lessons to avoid this in the future. If we go back about 100 years, we go to the 1930s and we can see the British government embarking on a project in the aerospace industry. They wanted Britain to be part of the industry to build and use airships. Airships were very popular at that time, along with seaplanes, but that's a different story. Britain had a project to design and build two airships, the R100, which I, if I recall correctly, was a private sector, and the R101, which was built by the chaps in the ministry. The R100 flew successfully all the way from Britain across the Atlantic to Canada and all the way back, no problems. The R101 set out on its mission to India and crashed outside Paris. This was a bit embarrassing. Within a few years, the airship programme was cancelled. I suspect that the government weren't really willing to put more money into a project and have further embarrassment of their side, despite the fact that the private sector airship was 100% successful. We never went on to pioneer an airship industry. We never went on to build a successful generation of airships. And perhaps with hindsight, that was a problem. By World War II, we could have had a successful airship industry, which could have allowed us to develop armed airships able to escort convoys across the Atlantic, defeat U-boats, and not have the massive crisis that we suffered in at least 1942-43 in the U-boat war campaign. Airships could have been successful in escorting convoys, saving thousands of lives, millions of tons of supplies. It might have shortened the war. It's interesting to note, though, that one of the engineers in the private sector airship project was a young lad called Barnes Wallace. He learned how to develop what he called a geodetic airframe. It's like a crisscross lattice that supports the airframe. It's very lightweight, it's very strong, and it was very successful both in the private sector, the R100 airship, and subsequently in the design and build of the Wellington bomber during World War II. It was renowned for its robust structure and its resilience to damage. And Barnes Wallace also went to make a bouncy bomb. You might have seen the movie about it. It was quite successful. After World War II, Barnes Wallace went on to design a new aircraft, an aircraft which he hoped would be the basis of a supersonic airliner, and which would give Britain, or help Britain continue its world lead in the aerospace industry, because during World War II, our industry was fantastically sophisticated, right through to developing and delivering the jet engine. The new aircraft developed by Barnes Wallace would have been the world's first supersonic airliner and would have given Britain a pioneering lead in supersonic flight as early as the 1960s. But never mind that, the chaps in the ministry weren't actually willing to approve of such projects. In fact, while Britain had a world leadership in the aerospace sector and everyone in the world came to Britain to see what we were doing in the aerospace sector, it was soon disposed of as being unimportant. The government and the chaps in the ministry had much better things to do, and our aerospace industry, started with airships, began to wither and die. You may say, well, hang on, what about Concorde? That was a supersonic airliner, yeah, but that required the French government to come up with the idea and then prod and poke the British government for years before the British government would approve. There wasn't really a vision of advanced aerospace enterprise, of advanced aerospace business in this country. The French subsequently went on to use their experience from Concorde to develop Airbus Industries, which has become one of the world's leading aerospace companies. Britain plays a small role making wings, but it's essentially a French-led project all the way down the line, not British-led. Although the aerospace industry was disposed of and tidied up and put away in a cabinet somewhere in London, in Whitehall, by the chaps in the ministry, British innovators continued to innovate. Aerospace opportunities may have been lost and discarded as being unimportant, but in the railway industry, in railway science and technology, British engineers were burrowing away with new innovations and innovative ideas to try and solve the fundamental problems facing this country. Unlike some countries, we haven't really got the opportunity to build long, straight tracks to allow for fast trains, so we had to invent clever stuff. One of these innovations was the advanced passenger train. You might have heard of it, you probably haven't. It was a train which was able to become a high-speed train on British tracks by being able to tilt and lean around corners. So it could maintain high speeds on our sort of wonky railway network. And that didn't work. Well, actually, it worked very, very well. But when they were testing it one day, some of the windows broke because it was going that fast. The glass wasn't up to the job. You can guess what happened next, can't you? The windows broke. It was a bit embarrassing for the government, so they decided to cancel the project. We weren't actually interested. It wasn't important. We could have been a world leader in advanced passenger trains. We could have had a high-speed rail network across the whole country by now, but we don't. In the 1960s, another great British scientist, Professor Eric Laithwaite, invented the linear induction motor. I won't go into all the science behind that. Suffice it to say, it allows a railway train to float on a magnetic field and then race off to another city very, very quickly, even faster than advanced passenger trains. You can guess what happened, can't you? We're not having any of that nonsense in this country. No, matey, no, we're going to stick with whatever we've got. And so it went on. I can't actually remember what really successful things Britain did in the 1970s, except something called North Sea oil. In fact, in the North Sea oil boom, vast amounts of money were poured into British science and technology and engineering. But that wasn't acknowledged by anyone really. Although the huge investment was far greater than the American investment in the space program to go to the moon. So they built lots of fireworks and went to that muddy ball in the sky. We just went out into the North Sea and got wet a lot. We also got very, very, very rich. In fact, it bailed out Britain's economy for the following 30 years. I remember the opportunities that were lost when we could have become very, very rich on airships, supersonic airliners. Well, we didn't, but at least we had North Sea oil flowing into this country, and we still have North Sea oil and gas flowing into this country to at least prop the economy up while we look for something better. In World War II, Britain was also remarkably successful in developing advanced electronics. We know about radar. Some of you may know about Colossus, the super secret project to build a supercomputer. And by the 1970s, British science and technology was still pioneering the world. We were on the cusp of developing advanced microelectronics, reduced instruction set computers and fibre optics. The General Post Office, as it was at that time, what is now BT and the Royal Mail, they were broken up into little bits and just flogged off for a quick profit. The General Post Office at that time was already making breakthroughs in optical fibre communications technology. But we're not having any of that nonsense. We can stick with good old dial-up telephones. We don't really need fibre optics. Britain was a world leader, but that was probably disposed of as unimportant. Similarly, in the 1980s, some scientists came up with the idea of using an air-breathing rocket engine to make an advanced hypersonic airplane, not just supersonic, but hypersonic aircraft that could fly all over the world, maybe even become Britain's first really good, successful, reusable space shuttle. Yeah, no, we're not having any of that nonsense either. In fact, we can go on and on. Time and time and time again, British scientists come up with revolutionary ideas, and time again, not important, really not interested. Part of the problem goes back to the fact that in the 20th century, Britain only had three major economic stimuli to massive growth: World War I, World War II, and the aforementioned North Sea oil. Now, I've mentioned North Sea oil because no one else has. North Sea oil was a revolution for this country. The massive engineering and scientific efforts kept British manufacturing going for decades, but you won't hear mention of that anywhere. World War I and World War II were seized upon by the political and bureaucratic establishment. They thought that their great visionary leadership had led Britain successfully through the wars. Central state control, central state management of the economy was so remarkably successful that they could do it in peacetime. No, not really. Yes, World War I and World War II were massive stimuli to the economy, but they just stimulated the flow of cash into the pockets of cranky inventors and innovators who then came up with the real technologies, which were then disposed of as not being very important. One of the other problems, the first one being, of course, the idea that centralised, organised economic management could save the economy, was the failure to understand that with science and engineering, it takes time to solve problems. Wallace, with his supersonic airliner and its variable geometry wing, swing wings that swing open and close for speed, were not important in this country, were not seen as critical as future potential because they weren't delivering immediate results. But sometimes it can take 20, 30, 40, 50 years to get the serious major results. Advanced passenger trains would have taken 20 or 30 years to master. By now, we could have a high-speed rail network across the whole country using existing track. We don't. We could have linear induction motors. We could have magnetic levitation trains racing between our cities as a supergrid of hyper networks. We don't. Instead, we now have a plan to build HS2, £100,000 million of gigantic project originated by the Labour Party as a massive infrastructural vision to revolutionise our railway network by buying a 1960s-style Japanese bullet train. It's not magnetic levitation. It'll do 250 miles an hour, but magnetic levitation trains could easily float above the ground. Not only that, a lightweight railway system using maglev could be built on stilts, and we would not have to gouge our way through the English countryside, demolishing villages and ancient woodland to make way for this HS2. So instead of investing long-term in British science, British railway technology, British aerospace technology, British computer technology, to master these industries and become world leader, all of these opportunities over the last 90 odd years were disposed of as being unimportant. Let me give you one last one to consider. You may be watching this on your smartphone. You may be watching this on a flat screen television on your laptop or your tablet. The first early flat screen technologies were developed in Britain in the 1960s with the advent of liquid crystal displays, small tiny things to display information, flat screen. But it took another 30, 40 years of continuous advanced scientific investment and engineering to seriously master to the point where you now have a convenient, low-cost flat screen in your pocket, in high definition, in full colour. That's the second fundamental problem of the British economic system. And it's not really a problem of the political bureaucracy. It's never been their job. But there needs to be a mechanism, a process, an underlying management philosophy for long-term strategic investment. The bulk of the British industrial financial economy is not rigged for that, but there are ways to create such mechanisms, ways to create alternative financial and economic institutions which can embrace new science and new technology in aerospace, in space technology, in computer science, in engineering and design. Britain still has phenomenal talent for success. There are still new opportunities which needn't be lost. But we need to create new models of business and finance, which can do the job not only of initial early investment, but of long-term scientific development, long-term engineering development, long-term design development. That's what I'm hoping to pioneer, so that the next century is not another century of opportunities lost.